Okay, we better get started. I have a lot of content to get through today. So first, thank you for coming along. I hope you've had a great Tech Ed so far. I hope you've recovered from the party last night and your brains are now back in gear, having warmed up with the first session of today. I'm Ben Armstrong, Program Manager on the Hyper-V team. I'm here today to talk about performance analysis of Hyper-V and performance information that you should be aware of. As I said, we've got a lot of content to cover today, so I'm going to dive right in. The first thing I want to do is to quickly talk about some of the performance information that we're starting to hear from our partners about Hyper-V. Now, I've had a couple of people come to me and say, hey, Microsoft isn't really publishing a lot of performance data about Hyper-V. What's happening there? And the fact of the matter is we've made a conscientious decision to not spend a lot of time publishing performance data about Hyper-V simply because we all know that you wouldn't trust the data that we provided because we're all a bunch of bastards and we lie all the time. And that's what you would think if you saw these great performance charts coming from Microsoft. You'd be, I don't trust them. So instead what we've been doing is we've been waiting for partners and for independent groups to come out and validate what we've been seeing internally as we've been developing it. So I'm just going to jump through a couple of pieces of information that have come out recently. So some points to just highlight for each of these. I have put in our URL links so that you're going to get copies of these slides afterwards and you can go and read up the extra detail. The other interesting thing is for each of the third-party pieces of data I'm going to jump through, all of these were actually done without contacting us first. It was kind of interesting. For each of these, we were only contacted when they'd run all the tests and got all the results. So the first one to mention is a performance test that Intel recently did, where they were able to show Hyper-V saturating a 10 gigabit connection and getting over 700,000 IOPS connected to a ginormous SAN array on the back end. There are a couple of interesting things that jump out about this particular test that they did. The first one is that this was done with a single physical box. This was a single physical box running 10 virtual machines and running their workload inside of each of those virtual machines. The next thing that was really funny was they actually they did this test, and they're like, this is great, you guys are saturating 10 gigabit. And as I mentioned, they did it without talking to us. And they came to us and they provided us all the details, and we actually found out that they hadn't configured the system optimally. They hadn't turned on a bunch of the network optimizations that we had. So we actually had some iterations with them where we're like, how about you now go and configure the system correctly and try that test again and see what it runs like. The next one, this was a really interesting one. This was done by Unisys. And they were focusing on testing our live migration capability. And what this graph actually shows is Unisys set up two of their really beefy high-end systems, loaded up a bunch of virtual machines, got a workload running, connecting to all of those servers, and they then proceeded to one after the other live migrate all the virtual machines from one server to the other. And the really nice thing to see is this blue line, because the blue line is the aggregated number of transactions that were able to be supported between the two virtual machines. And as you can see, we were able to maintain a fairly solid rate of transactions, even though over the course of the test, the workload was entirely moved from one computer to another. The next one to talk about, this one actually only came out recently, and this is a really interesting one. This was done by a group called Principled Technologies. And their specific goal with this test was, given their workload, to go out and buy hardware, software, everything to meet a specific performance bar that they had set, and then to look at, okay, what was the cost of VMware versus Hyper-V in order to reach our performance goals. And the net takeaway that they got was, it ended up being kind of the same. So really interesting read So I highly recommend you go and look at that. Next I want to talk about is Virtual Reality Check. And if you haven't been following these guys, I strongly recommend that you do. They're an independent group that's been doing a lot of work looking into virtualization performance in general. And they've just been producing some really quality work. I've been following them avidly, and I love reading their write-ups. They've done a number of tests. Their latest round of tests was looking at running terminal services inside of virtual machines. Now, if you've been using virtualization for a while, you know that terminal services has always been kind of like the horror workload to run inside of virtual machines from a performance perspective. Now, thankfully, with recent changes in hardware, this has really turned around, and it's now fully possible to run terminal services in a virtual machine and to get great performance out of it. Now, they tested 2003 and 2008, and these are the results they came up with. As you can see, for 2008, it was pretty much tied between Hyper-V and Xen. For 2003, Xen just beat us out a little bit, and that was Hyper-V and VMware. But really interesting and great results to be seeing coming out. So now that I've jumped through that, I want to spend some time to go over performance information and performance best practices. And hopefully, you're going to know a bunch of this stuff already. Hopefully there's going to be a bunch of this stuff which is just going to be kind of reaffirming for you that like, oh yeah, we're doing the right thing. But I make my personal guarantee that there will be some new information in here. I told Stu I'd say this ahead of time, so my guarantee is that if you learn nothing new from today's session, talk to Stu Fox here afterwards, and he will personally refund your cost of attending this show. Right, Stu? Yeah. Seems to be having a bit of a problem with that. So some general things. Once again, hopefully this is not new for anyone here. Having integration services installed is critical. It's also important to have them up to date. I have lost track of the number of times we've spent time doing performance troubleshooting only to find out that, oh, this virtual machine didn't have the appropriate latest version of the integration services. And I'd like to use this as an opportunity to put a sales pitch out for the Hyper-V Best Practices Analyzer. How many people here have had a look at that? We got a couple of hands. I actually love this. I run this tool all the time because one of the things that the Best Practice Analyzer does is goes out and it checks over all your Hyper-V VMs and lets you know if the integration services aren't up to date. And I was surprised that with my personal server at home, when we first released the BPA, I installed it and I ran it to go, oh, what results is it going to come up? I had 2 VMs which had out-of-date integration services. I was horrified. I should know better. The next thing, this is kind of an interesting one. And this is, if you want the best performance out of your virtual machines, run the latest version of Windows. And that kind of goes contrary to what most people think with performance. Because most people sit there and go, well, if I had an old piece of hardware, I'm going to run an older version of Windows on there because it has less overhead. But the fact of the matter is, you take Windows Server 2003, and it was not designed with virtualization in mind. Microsoft wasn't thinking about how to make this run well inside of virtual machines. That only started happening with Windows Server 2008 and 2008 R2. In fact, today, we say that we only support Windows Server 2003 Service Pack 2 on Hyper-V. And that's because we actually went back and we made some changes to Windows Server 2003 in the Service Pack 2 release to make it run better inside of virtual machines. And with every release of Windows that we've done, we've worked very closely with the Windows team in order to make it a better and better client for running inside of virtualization. So you'll see better performance out of 2008 than out of 2008 or 2003. You will see better performance out of 2008 R2 than you will have 2008. So if you have an option, I understand there are times when you have software requirements and it's not an option. But if you have an option, always go with the latest version of Windows running inside the virtual machine. The next one, this is also kind of an interesting one, and that is, whenever possible, don't leave your management tools open. And this is interesting for two reasons. The closing Hyper-V manager or whatever, that's actually fairly simple to explain. We have this nice little list of virtual machines, but what we're really doing is we're constantly going and talking to the parent partition to get information about virtual machines so we can display that nicely formatting list. And it's not a big overhead, but hey, you get 50 virtual machines on there, and that's probably going to be 2-3% CPU usage ongoing while we're continually going back and going, hey, what are your latest stats? What are your latest stats? The really interesting one here is the virtual machine connection. And it gets really confusing talking to people about accessing the virtual machine desktop because you could be using the virtual machine connection, you could be using remote desktop. The term we use internally is we talk about the glass console session. And this is what you would get if this was a physical server and you went and sat in front of it. And the glass console session is what showed through the virtual machine connection. Now, what a lot of people don't know is that if you close that and there's no active connection to the glass console of a virtual machine, we actually turn off large swaths of our video emulation code. Because emulation is one of the most costly things in virtualization, and we know that we can save a bunch of resource. So we turn off parts of our video emulation code. In order to display this, we're actually running an RDP encoder. We turn that off if no one's connected. So there's a noticeable saving to turning VM Connect off if you're not using it. And it's something that I always recommend is that if at all possible, use remote desktop to connect directly to the guest operating system. Because you do that, and we're not running this video emulation code, but you're still getting your full desktop experience. And the second final one for this section, I have to beat this drum. Don't run things in the parent partition. A key thing to understand here is that the way Hyper-V is designed, the parent partition is treated specially from a resource scheduling point of view. And the reason for this is because virtual machines often require the parent partition to do something for them. So whenever a virtual machine touches an emulated device like the video, it requires the parent partition to do something for it. So in the Hyper-V scheduler, if we see a virtual machine that's blocked, waiting for some activity to happen, and we see work that needs to happen in the parent partition, we go, okay, we're going to schedule the parent partition, we're going to let it run so it can get that virtual machine unblocked. Now, if you've gone ahead and installed SQL in the parent partition, what's going to happen is SQL is going to run instead of our emulation code, and the virtual machine is still going to be blocked until the next time around. Now, this isn't going to cause your system to crash, and it's not going to cause catastrophic problems, but it will cause a noticeable performance degradation in your virtual machines. So whenever possible, put these workloads in virtual machines. Don't put them in the parent partition. Keep the parent partition just for Hyper-V and key things that interact with Hyper-V. For example, DPM. If you're running backup, it's okay to have the backup agent and so on. But don't go sticking unnecessary server roles and server apps in the parent partition. The final thing, I'm going to talk about this in detail in the next couple of sections, is when you're measuring performance, don't measure from inside the virtual machine. Pretty much every counter is wrong in some way. One of the most interesting aspects of virtualization is we mess with time. We mess with time all the time. And especially at a scheduler level at the millisecond timer, things aren't that accurate inside of virtual machines. We have a lot of logic to make sure that by the time you get up to the second timer that everything comes out in the wash. And this works fine for all the server applications out there, but when you start running benchmarks, when you start running detailed performance counters inside of virtual machines, they're just not reliable. One of my pet peeves, as combination pet peeve / something that makes me laugh, is when I go out there and I see a third-party benchmark that's been written. There'll be some blog post about it, And what they're showing is that, and I've seen this for our platform, I've seen this for competitive platforms, but they'll show that like, hey, on this platform, the virtual machine had 4 times faster disk performance than raw hardware. You're like, that's not possible. That doesn't happen. You see that, and what that tells you is, oh, your performance test is broken inside of virtual machines. Throw those numbers out. So whenever possible, we expose a lot of performance counters from Hyper-V itself. And wherever possible, you should use those. Because we also mess around with some of the performance counters in the parent partition. Not as much as inside of virtual machines, but it definitely happens. So whenever possible, use the Hyper-V performance counters. So now I'm going to jump into some specific guidance around processor. Processor for the longest time has been like the biggest area of focus for virtualization. And as a result, there's a lot of good performance work that's happened here, but there's still a lot of information to know. So the first thing to know is these are the performance counters that are exposed from Hyper-V in the parent partition that you want to look at. The first one is really useful. This hypervisor logical processor total runtime. This is your one reliable point in the system that tells you how much CPU usage is happening on the box. There is no other counter on a Hyper-V system that will actually tell you reliably how much CPU is being used. Because every other counter doesn't include CPU time spent in the hypervisor. This is the only counter, and this counter takes CPU time spent in the parent partition in each of the virtual machines and inside the hypervisor itself and gives you a figure. That's the number you need to look at. Then for virtual machines, you should use this guest runtime. Just to highlight, do not use Task Manager. And I'll be showing you why in a demo later. But once you're using these counters, you can apply usual CPU logic. If you see these counters at high loads, that's an issue. You need to go and figure out what's happening, what's causing that high load, and figure out if you need to move virtual machines off. The next thing to talk about is processor consolidation ratios. So we talk a lot about how many virtual processors you have per logical processor. So, you get a system which has 4 CPUs, they're 4-core CPUs. You have 16 logical processors. And we want to know then, how many virtual processors do you have assigned to virtual machines? Our recommendation is that a good number to aim for is 4 virtual processors per logical processor. And if you're not at that number, fact of the matter is you're underutilized. I mean, that's great. You're not going to have performance issues, but you're not really getting your money's worth out of the hardware. As a top limit, we support 8 virtual processors per logical processor. And something to just touch on there is that we have had various partners come to us and say, hey, we tested this workload, and we were able to run at 12 virtual processors per logical processor. And we acknowledge that, hey, it's not a hard line. We haven't put a hard limit in there. We have only tested all of the workloads we know on 8 virtual processors to 1 logical processor, and that's the limit that we support. What happens if you go over that limit is that responsive times start to get stretched inside of the virtual machines. So things like I/O response starts to take longer and longer inside the virtual machines. So quite often when people have come to us and said, hey, we're running 12 VP to 1 VP and it seems to be running fine, they're talking about running a VDI workload. And our response is, well, that's great, but like if you were doing 12 VP to 1 VP and it was a SQL workload, I doubt that you'd be telling us that everything was fine. So as a general rule of thumb, if you're at 4 to 1 or lower is fine. You'll be fine for performance, not getting your money's worth, but 4 to 1 is a good number to aim for. If you start seeing this getting up towards the 8 to 1, that's a sign that you need to figure out how to reduce the number of VPs in the system. As a little side note, I did a blog post on this recently. It turns out we don't expose anywhere in the system directly that tells you your virtual processor to logical processor ratio. So I came up with this truly cryptic single line of PowerShell that will give you your virtual processor to logical processor ratio for your system. Very handy. I was pleasantly surprised to discover that my home system was running at 3.75. So I'm right on the utilization spot there. Now, a really common question that I get around virtual processors is, how many virtual processors should I have per virtual machine? You know, for a long time, the guidance has been, you know, if at all possible, use one VP and only use multiple VPs if you have a workload that utilizes it. And there's a couple of things I'd like to say here. The first thing is that, yeah, you know, having more VPs in a system does add overhead. You know, that's a fact of life. But there are some other points to consider. The first one is that we've done a lot of work working with the Windows team to reduce the overhead of running multiple VP systems. And this gets back to my comment about you want to run the latest version of Windows, because the newer versions of Windows, the overhead for running multiple VP virtual machines has just continued to go down. The second thing to highlight here is that the overhead that we discuss here is overhead that is taken on by Hyper-V. It is not overhead that is taken on by the virtual machine. What I mean by this is, let's say you have a workload that doesn't take advantage of multiple processors, but you still want to make it a 2-VP system. This is something I do all the time. In fact, this is something that every server admin wants to do, because if it's a server, it needs to have 2 processors. You know, that's a fact of life. But if you do that, you're not going to slow down the virtual machine. The virtual machine will continue to run at the same performance that it used to run at. What you're going to do is you're going to make Hyper-V use more of your processor time in order to run that virtual machine. So you will increase the overall CPU utilization on your box, but you're not going to slow that virtual machine down. And where that increase comes into effect is simply that if you have a box where you're at the CPU limit, if you have a box where you're looking at the total runtime counter and you're at that 75 to 80 to 90%, that is where you should be going, okay, maybe I should look at, do I really need all these VPs around? But if you're not getting high up in the CPU utilization, there really isn't that much of a downside to having these extra virtual processors around. So all in all, my guidance here is that assign VPs judiciously. Don't be silly on either side of the fence. You know, don't go around going, all my VMs have to be single VP because that's best for performance, and then be having availability issues because you've got servers where you should have given them 2 VPs so you had the availability of 2 VPs. But on the flip side, don't be sitting there going, well, Ben said there's no overhead to this, so I'm going to create every virtual machine with 4 VPs. No. No. Use your head and plan it logically. 2 final points that I want to make here, which are tied together. The first one is Microsoft has made support statements where for each operating system we support, we've stated, for this operating system we only support 1 VP. For this operating system we only support 2. For this operating system we support 4. An important thing to understand is that when we say we support 2 VP or 4 VP on an operating system, what we are saying is that it performs well. That by adding these extra VPs to that operating system, you will get improved performance. Because that is our first bar that we look at when we're looking at supporting multiple virtual processors for a system. We start by looking at performance tests. And if we have a system where we can't get improved performance by adding extra virtual processors, we're not going to continue testing and qualifying that configuration. So the classic example here is Windows Server 2003. As I mentioned, wasn't designed with virtualization in mind, and in fact is a Windows 2003 RTM is a real bear to get running in virtual machines with multiple processors, full stop, let alone to get it running in a way that performs. In Windows Server 2003 Service Pack 2, we went in, we worked with the Windows kernel team, we made some strategic changes in order to get to address some of these performance issues. But it's still not a great system for virtualization of multiple processors. So what we see in our test today is that, yeah, you can run a 2 VP Windows Server 2003 system, and it does perform better than a single VP. However, if you run a 4 VP Windows Server 2003 system, you don't get any performance benefit. In fact, your performance goes backwards from 2 VP. And that's why we say, for Windows Server 2003, we only support 2 virtual processors. I every now and then have someone come to me and say, hey, I tried it and it works. And it's like, hey, it's great, yeah, it booted. Did you actually try running a workload? Did you actually see what the performance you got from it was? So moving on, the next thing to highlight is some of the new hardware that's come out. Virtualization is actually a space where there's still a lot of evolution happening in the processors and in the chipsets. It's something that doesn't get talked about a lot, is that with every generation of processor that's coming out, hardware virtualization is becoming more and more efficient. So I certainly have systems in my test lab where if you look at them just by their number of cores, by the clock speed of the processor, you would say, yeah, these things are about the same. But the CPUs are 2 generations apart. And the result is that Hyper-V runs, about 30% faster on the newer CPU than on the older one. One specific piece of hardware change that's come out recently is second-level address translation. And first, I will apologize. Second-level address translation is a term that we invented. And the reason why we invented it is because, A, AMD and Intel have never been able to agree on a name for it, and B, in the case of AMD, they even changed the name around. So we call it second-level address translation. AMD calls it RVI, sometimes NPT, and Intel calls it EPT. So 2 little stories around the naming. The first one is the reason why AMD has the 2 names for this is because AMD actually released this technology first, but they didn't do a big marketing thing around it. When Intel released the technology, they did more marketing effort around it, and AMD said, hey, we got to show that we have a competitive technology, and their response was to change the name so that they could come out and say, well, we have this new technology, RVI. So that's a bit frustrating. The other thing that's a bit amusing to those of us on the Hyper-V team is that one of the top engineering positions at Microsoft is the distinguished engineer. We have a single distinguished engineer on the Hyper-V team, and his name is Eric Trout, and his initials are actually EPT. So we had a good laugh when Intel started talking about, we've got this EPT feature. We're like, we've got an EPT feature too. He does great things for performance. So the final thing about this is, unfortunately, neither AMD nor Intel have been very good at communicating which processors do and don't have this technology. The guidance I've received from them is with AMD, any Phenom processor that has hardware virtualization support has RVI. For the Opteron processors, the specific guidance is if it's an Opteron processor that's quad-core or greater and is generation 3 or greater, it will have RVI. Intel is a bit cleaner. If it's the Xeon 5500 series or any of the Core i7 or i5 or i3 that has hardware virtualization support, it will have EPT support. So the next thing to quickly touch on is the hyperthreading question. Now, for those of you who've been around for a while, you'll remember back when Intel first did hyperthreading on the Pentium 4, and it was not a pretty picture. They enabled hyperthreading, great, my single processor now looks like 2 processors magically, but oh wait, if I put full load on those 2 processors, I get worse performance than my single processor. And in fact, at that time, there were a lot of server apps which were coming out and providing guidance to say, hey, turn off hyperthreading. It's just a bad thing. So Intel learned their lesson from that. They released a couple of generations of CPUs without hyperthreading, but they have just recently started doing CPUs with hyperthreading again. And there are a couple of points to make here. The first one is that the new hyperthreading is not like the old hyperthreading. It doesn't have the performance issues of if you load the system up, you get worse performance. So you're not going to see this wave of people saying, hey, turn it off. It's causing performance problems. That said, the new hyperthreading does not magically double your performance. It is simply a technique for allowing software that isn't written to take advantage of Intel's new processor architectures to get better performance. Well, guess what? Hyper-V is written to take advantage of Intel's new processor architectures. So with the new systems, hyperthreading on or off, you're not going to see that much of a performance difference with Hyper-V. And it's fine to leave it on. The one piece of guidance that I would give is that when you're doing your VP to LP calculation and you're trying to figure out how many virtual machines I can fit on this, don't think that hyperthreading magically doubles your number of LPs. No, it doesn't magically let you run twice as many virtual processors as you could before. So when you're doing that calculation, be thinking about physical cores on my processor, not hyperthreads. So now I'm going to move on from processor and spend some time talking about memory. The first obvious thing to say is like, hey, the story here changes completely with dynamic memory. So today I'm going to try and touch on what you should be looking at for systems without dynamic memory and what you should be looking at for systems with dynamic memory. So either way, the first piece of guidance that I have to give is leave enough memory for the parent. Hyper-V performance really goes down the drain if you starve the parent of memory. And trust me, you will know if you've starved the parent of memory. Windows take ages to open, the mouse is unresponsive, it is not a pretty picture. So without dynamic memory, this is actually fairly simple. Just don't start too many VMs that use too much memory. And if you start to see performance issues, turn off the last VM and lower the amount of memory. One point to make here, and I've had this discussion a number of times, is it is better to have paging happening inside the virtual machine than to have it happening in the parent partition. And the reason for that is if you have a single virtual machine that's paging, that only affects that virtual machine. Your other virtual machines are fine. But if the parent partition is out of memory and is paging, then that's going to affect the performance of all virtual machines on that system. And that's a bad thing. With dynamic memory, everything should just work. And I say should because, hey, we just released the beta and we're waiting to hear what people say. But we do know that there are going to be times when dynamic memory doesn't provide enough memory for the parent partition. The most common one is when people don't follow my earlier best practice and they put another workload inside the parent partition. And for that reason, we're actually providing this registry key that I've mentioned here, which allows you, with a dynamic memory system, to go in and manually specify how much memory should be kept for the parent partition. So if you're running another workload, you can go in and say, okay, look, parent partition needs 2 gig of RAM. And that will ensure that we never chew up the last 2 gig of RAM for virtual machines. So now, looking at what should you be thinking about if dynamic memory is not in the picture. First and obvious one is just standard memory sizing practices to make sure that the virtual machine has enough memory. And this is just like on physical computers. An interesting point here, available megabytes is a good counter to look at. Page per second is not. A lot of people don't realize this, but with Windows Server 2008 and Windows Server 2008 R2, anytime we're doing file cache operations, that causes the page per second rate to go through the roof. So you can see a system that is doing fine from a memory point of view, and we're swapping stuff in and out of the file cache, just trying to optimize the file performance with the free memory that's left over. That'll cause a high page per second rate. So don't be looking at that counter. Another good counter to look at is the committed memory counter. This is actually, every time I talk about committed memory, there's always someone who goes like, oh, but I can write a simple test app that messes with committed memory. You can't trust that counter. And yet, you can write a test app that messes with committed memory. That said, we have yet to find a real-world app that messes with committed memory. And I actually say that with relative confidence because we did find one real-world app that messes with committed memory, because any app that messed with committed memory would actually cause big problems for virtual PC, virtual server. So there was an old version of Nero NCD that would always set its committed memory to 2 gig, even though it wasn't using any of it, and we got all those support calls. So apart from that, I haven't come across applications that mess with this. And committed memory is a really good counter to look at, because committed memory gives you some insight into what your applications actually want, as opposed to what they currently have. The next thing to highlight, this is probably the most common mistake with memory sizing, is if you're doing a P to V of a physical computer to a virtual machine, 9 times out of 10, people just go, well, the source computer had 2 gig of memory, so I'm going to give the virtual machine 2 gig of memory. And they don't take the time to figure out, was the source computer well configured? You know, because if the source computer had 2 gig, but it's sitting there not using half the memory all the time, well, don't give the virtual machine 2 gig, give it less. For all you know, the source computer may be paging, and it may just be that we were getting by on performance, and it actually needs more memory. So when you're doing a P to V, use that as a good opportunity to understand the workload and to make sure that the new virtual machine is sized appropriately. For the dynamic memory side, things actually get a lot simpler. We have this really handy performance counter in the parent partition, average pressure. And here's the simple lines. If average pressure is less than 80, you're great. If it's between 80 and 100, you're running, but you probably want to stop loading the system up. You're getting close to capacity. If you see average pressure go over 100, that's our message to you. Virtual machines are paging. We are out of memory. It's time to shut down some workloads or migrate some virtual machines out of here. Another comment on dynamic memory is we have the configurable memory buffer. It should be set, it's set to 20% by default. You should set it higher for workloads like IIS or file server, where they'll benefit from having a large file cache. You should set it lower for workloads like SQL, which will try and chew up a lot of memory, because this helps keep them in check. So now I'm going to quickly jump over to my demo. This is just a short demo to highlight some of the stuff that I've talked about with not trusting performance counters. Just wait for my laptop to wake up. So the first thing I want to show on this is my laptop. It's got a quad-core processor in it. And at the moment, I've just got 2 virtual machines on here. And they're both set up with 4 virtual processors each. I've got Task Manager up in each of them. And I've got Task Manager open in the parent partition. So if you were to look at Task Manager across all these 3 environments, and these are the only virtual machines that are running on the system, you would say, yep, that's a pretty idle system. That's doing nothing. Yet, if I go to perfmon in the parent, and I have a look at the total runtime counter that I mentioned, you can actually see there is still a little bit of activity going on in the system. You know, more activity than was indicated by Task Manager. And because what we're seeing here in this 1 or 2% bubbling along the bottom is the work that's being done by the hypervisor to just switch these idle virtual machines in and out. And that's workload that doesn't get reported anywhere else. So the next thing I'd like to show is why you shouldn't use counters inside the virtual machine. So I'm going to come over here to my first virtual machine. I'm going to run this handy little app that I have that will cause my laptop to melt down. And this is an app that's going to just keep all 4 VPs at 100% CPU load. So you can have a look at Task Manager and you can see they're all up there. Now, if I go back to my Performance Manager in the parent partition, here I've grabbed, I'll just quickly show you because I set these up ahead of time, but all the Hyper-V counters are in the parent partition and they all start with Hyper-V. It's really simple, but we have a ton of counters in here. The one that I'm looking at here is the Hyper-V hypervisor virtual processor %guest runtime. Now there's a counter for each virtual processor. Because that would make this graph a little bit messy, I've just grabbed the counter for the first virtual processor in my first virtual machine and for the first virtual processor in my second virtual machine. So what you can see here is that for the most part what I'm seeing through the Hyper-V performance monitor is matching what's happening inside the virtual machine. The virtual machine's pegged and the first virtual processor in the virtual machine is getting close to 100%. So that's all good. But now we can make things really interesting. So I'm going to go over to my second virtual machine and I'm going to start the same workload. Now the interesting thing to point out is that Task Manager over here hasn't indicated any change. It's still going, I'm at 100% CPU. Task Manager over here is also saying, I'm at 100% CPU. Now they can't both be at 100%. I don't have 200% processor in the system. If I come back here, you can see, look, even though Task Manager inside the virtual machine doesn't know that anything's happened and still thinks that it's getting the same throughput it was before, that virtual processor is now getting half of what it was getting before. And in fact, if I come back to my second virtual machine, I will slowly kill off these processes. And what you'll see is that as I kill them off, the red line's going to progressively jump around a bit as it gets some more scheduling time, as things get freed up. So my goal here is just to make this line as erratic as possible. So I think that's a nice little zigzag there. And if we go into this virtual machine, once again, it has no idea what's happened. It doesn't think anything has changed in regards to processor utilization. So this is that's the length of my demo, but just to highlight that do not look at performance counters inside of virtual machines. You never get the full picture, and the picture you get is quite often far from the truth. So it's a bad idea to be looking there if you're trying to figure out where performance issues are happening and what changes you need to be making. Okay, got a lot of material to cover and we've got to scream through this. So next thing is to talk about storage. First, a little comment before I get on. One of my big expectations is that with dynamic memory, that people are going to be able to run more virtual machines. They're going to get past the memory bottleneck. The next thing they're going to hit is the storage bottleneck. So I expect to be talking about this a lot in the coming year or two. So this is, with storage and networking, this is an area where you can use the counters in the parent partition. So the best counter to look at here is your average disk read-write time. And if you start seeing this getting too high, then performance gets really bad. So that's a good counter to look at. The other is the transfers per second. I love this little fact here, because you hear us talking about IOPS all the time. So if you want some perspective, a floppy disk can do 1 IOP. But those are good counters to be looking at to figure out, am I seeing a storage bottleneck here? Because quite often it's not obvious that you're bottlenecking on storage. You'll be seeing virtual machines that are sluggish, slow to respond, and you'll probably be thinking, have I overloaded the CPU? Do they have enough memory? And you won't be thinking, is the storage fast enough? The next thing to talk about, this is a little cliche, but hey, SSDs are really good. And specifically for Hyper-V, they're really good because, one of the things that people talk about with SSDs all the time is the throughput. Well, and they get better throughput than spinning Meteor, and that's great. And the throughput certainly benefits Hyper-V. But the real benefit is the seek time, because you get a bunch of virtual machines running on a single physical media. And even if those virtual machines are doing sequential read-writes, by the time we've done scheduling for all those virtual machines, we've essentially randomized the read-write pattern. And I had a question about this when I talked about this in Australia. If you're running like a single big virtual machine like SQL, and you're running it on dedicated disk, you're not going to see as much of a benefit from SSD. Like, it'll definitely benefit it, but SQL's already doing the work to try and make sure all I/O is sequential and operates well. But if you have a situation where you're running dozens of virtual machines off a single disk, you will see a huge boost from running SSD. So that's something to think about. Next, I want to talk about all this information, by the way, for the next couple of slides, is going to come from Virtual Hard Disk Performance white paper that we published a little while ago. When you get the slides, you can just click on that link and it'll take you to it, and it's like 20 pages long, and it goes into great detail about this. But the first thing that I want to say is please, 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 please never use physical disks or pass-through disks for performance reasons. This is something I've been saying for a while now, but you can see here, this is a performance test where we tested fixed-size VHDs as compared to physical pass-through disks. And on every test, and a little thing to highlight, this is both 2008 and 2008 R2, the two platforms pretty much equal. So never, like from this point on, if anyone in this room comes up and tells me, oh, that virtual machine, we're using a physical disk for performance, I reserve the right to slap you. It's not the reason to use physical disks. And you should understand that when you use physical disks, you give up the portability of virtual hard disks. You give up a lot of cool features of Hyper-V, like the ability to do host-initiated backups. I don't use physical disks in my environment. I only use fixed VHDs. So please, please, please do not think that you have to use physical disks in order to get the best performance. The next thing to talk about is the performance of dynamic disks. With Windows Server 2008 R2, we did a lot of work to improve the performance of dynamic and differencing disks. And to just highlight, this graph's a bit of an eye test, but if you have a look here, this dark orange bar is dynamic disks as compared to raw disks. This one down here is 2008's dynamic disk performance. So there are a couple of things to take away here. The first one is, if you're using 2008 RTM, please do not use dynamic disks if you care about performance. If you're using R2, on the other hand, consider dynamic disks. They allow you to do thin provisioning, and the performance is pretty close. And the reason for this difference, by the way, is because this is a combined read-write test. Dynamic disks incur an overhead when you're writing to a new sector of the disk. They do not incur any overhead when you're reading from the disk or when you're writing to a sector that's already been written to. And if you get this white paper, you can see they did some raw read tests of dynamic disks, and the performance was pretty much the same. Another interesting characteristic of the it doesn't hurt to write to a sector that's already been written to is that the longer you run these benchmarks, the closer the gap becomes, because you start writing over the top of sectors that you've already written to. And it's a similar story with differencing disks. Once again, if you're running 2008 RTM, think twice before using differencing disks in a performance-sensitive environment. But with R2, the performance is much better. But also, just like with dynamic disks, there's little impact to reads, but there is an impact to writes. So that's something to be thinking about as you're sizing these environments. So second last point on storage. I want to spend just a moment talking about iSCSI. First, I'm going to jump to the bottom of this slide. This is something that I get asked all the time, is how should I be using iSCSI with virtual machines, and how should I be using iSCSI with Hyper-V? unsurprisingly, my first answer is do not use physical disks, do not use pass-through. Your first and best option is to connect iSCSI to the iSCSI device to the parent partition and store virtual hard disks on it. Your next best option is to use an iSCSI initiator inside the guest operating system. So a couple of other points here. The summary of most of this slide is pretty much follow your iSCSI best practices, use isolated networks, and turn on any network optimization that you can possibly get working reliably with your infrastructure in order to get the most out of iSCSI in your environment. The final point that I have on storage, this is just kind of an interesting side point, is whenever possible, remove the CD drive from your virtual machine. I don't just mean leave it empty, but I mean actually go into the virtual machine settings and remove the drive. And the reason for that is Windows will go around to a CD drive once a second and say, do you have anything in there? And when it does that inside of a virtual machine, we actually have to go from the virtual machine down to the hypervisor, up into the parent partition, into a chunk of emulation code running in user mode in the parent partition just to say, nope, it's empty. Then it goes all the way back. And the reality is this doesn't have a huge impact, but where this does come in is if you have a bunch of idle virtual machines. We have done testing on systems where we've shown if you have, a dozen idle Windows Server 2003 virtual machines, going through and removing all the CD drives will save you about 2 to 3% CPU. Not a big thing, but just a little tip to keep under your belt. What I actually do is once I've got my operating system set up and once I've got integration services updated, I remove the physical CD and I install virtual CD software inside the virtual machine. That means we're not doing this trip out to the parent partition every time Windows tries to check if there's a drive in, CD in there. I actually don't have a strong preference. I've used half a dozen, so I haven't hit problems with any of them. So any that you like. There's Virtual Clone Drive, Alcohol 128%, Daemon Tools. I've used all of those, and I haven't had any problem inside of virtual machines with any of them. Now I'd like to jump on to networking. The first thing, let's talk about some of the counters. One of the best ones to look at is the output queue length. And the first place you should look is you should look at the output queue length on the physical network card. When you go to perfmon, you will see counters exposed for the physical network card and also for the virtual network card that we expose into the parent partition if you've selected that option. You should be looking at the physical network card. Next point, and I'm not going to talk much about this, I'd highly recommend that if you're setting up a cluster for live migration, that you go and you have a look at this network configuration guide. It's a really handy document that goes through and talks about all the different configuration options that you can have in that environment. So hopefully this one is a, well, duh, obviously, but don't use legacy network adapters. Use the standard network adapter. You should only ever use legacy network adapters in order to do PXE boot. And in fact, what I do PXE boot all the time. And what I do is my new virtual machines, I give them a legacy and a standard network adapter. And the moment the OS is installed, I shut down, pull the legacy network adapter out. A key thing to understand is not only are legacy network adapters slower, significantly slower than standard network adapters, but even if you have a virtual machine where you're like, performance isn't a big deal. Network performance isn't a big deal for this virtual machine. Having a legacy network adapter in a virtual machine means we're going to be running more emulation code anytime the network gets touched. And when we run emulation code, we slow down the entire virtual machine, not just the networking. So if you have, let's say you have a CPU-intensive load that's occasionally touching the network, if you have a legacy network adapter in there, your CPU load is going to run slower than if you have a standard network adapter in there. So that should be a default starting point. The next point is we actually have a ton of support for various hardware offloads that are out there for virtualization today. We have support for the VMQ technology. We have support for Chimney, for TCP/IP offload, for jumbo packets. The list goes on. The bummer about this is they're all actually really hard to turn on. We do not have a good configuration UI around tweaking all of this. It would easily take me half an hour just to step you through how to turn each of these options on and off and talk about all the details. So rather than doing that, there is a fantastic white paper that we've recently published. If you have high-end server networking hardware, go read this white paper and figure out what's appropriate for your environment. The final point that I have for server networking is, and this is probably the biggest point, is you get what you pay for. You know, if you really care about server networking performance for your virtual machines, go out and pay for good server class networking. Almost every time that I come across people running, you know, the cheap $10, $20 network adapters, like these are the list of issues that we come across. You know, poor throughput is an obvious one. High CPU utilization, that's an interesting one. I actually hit this back when I was doing performance testing on virtual server. I had two boxes that were identical, except one had a nice Intel server class network adapter that probably cost Microsoft $250. Now, interestingly, the other one also had an Intel network adapter, but it was a desktop adapter that had probably only cost Microsoft $20. And I ran my performance test on both of them, and both virtual machines got the same amount of throughput. But when I went and I looked at the CPU performance on the system with the high-end card was using 10% CPU, whereas the system with the cheap one was using 60%. And the reason why was the way Intel had saved costs on the cheap card was by taking things out of the hardware and putting that logic in the driver. So that's a big thing to consider. I've also seen, actually one of the first things, if I ever have someone come to me and say, you know, I got this virtual machine that just seems to randomly drop the network connection. My first response is, what network card are you using, and have you tried a different one? And 9 times out of 10, A, they tell me they're using a really cheap, nasty network card. And B, if they go and get a decent network card and they try it, the problem goes away. So that's all I have to say, and we actually have a couple of minutes still. I'm impressed that I actually managed to bring it in. So thank you for your time. I'd like to request, please remember to fill out your eval forms, and at this stage, do we have any questions?
With the comment about legacy network adapters and still be there for Pixie, is there any roadmap to support Pixie?
So unfortunately, I have to give the answer that I'm not allowed to talk about future roadmaps. So I can't answer that.
What about teaming? Because we've had issues with Broadcom spinning up split dark packets from previous hosts.
Yep. So the question is, what about teaming? So that's actually a really good question and a really hard question to answer. So I'll try and hit a couple of the top points. The first thing to understand is we have been working really closely with a number of our hardware vendors so that they can get better support for teaming of Hyper-V network adapters. So these days, Intel, Dell, HP, Broadcom all have papers that they've put together, and most of them, unfortunately, some of them are still working through issues, so most of them you want to go and find the latest driver you can. It's a really tough question to answer around the question of what's best for performance in regards to teaming. When you set up a teamed network adapter and you're able to use it with a virtual machine, it's great because you get the bonded channel and you get the bandwidth of both connections, and that's fantastic. However, at the same time, most hardware vendors out there today actually require that we turn off a bunch of our network offload optimizations if you're doing teaming. So for instance, I mentioned we have support for VMQ in R2, great functionality for performance, but it doesn't work if you do teaming. And so unfortunately, it's going to be really workload dependent. If you have a workload where what your focus is is total aggregate bandwidth. You should probably be looking at teaming. If you have a workload where you're going to be running a lot of virtual machines, and you're not going to have a single virtual machine that exceeds the bandwidth of one card, and your focus is more so on keeping the overheads low and getting as close to wire speed as possible, then I would advise against teaming so you can use those offload technologies. The final comment that I have on teaming is if you're serious about deploying teaming in your environment, my top recommendation is go and engage with a hardware partner and say, hey, we're going to buy some hardware to do teaming as long as you can get it to work, because they will help you out.
With the dynamic disks, you're showing that they're still a little bit down in performance. Does that get any worse if you use them on CSVs?
So the question is, does dynamic disk performance get worse if you use it on CSV? The answer is no. CSV doesn't affect disk performance either way. And we are out of time now. So once again, thank you for your time. I'm actually going to go and hang out in the expo hall if you want to come and ask more questions. And please fill out your eval forms.